Hello, data science learners. Welcome to a new deep dive. Building on our previous talk about anomaly detection and how identifying deviations works, let us explore ensemble learning. Most videos on ensembles never show the raw geometric intuition of how collective errors vanish. In this video, we want to show something different, the surprising way a crowd of incorrect models can reach a near-perfect truth. Imagine a single person standing before a large jar filled with jelly beans. They make a guess, but it is just a guess. In the world of machine learning, this is like a single model trying to predict a complex outcome. Because of its limited perspective, this model will almost certainly be off the mark, influenced by its own biases or the specific noise in the data it was trained on. Now, let us consider a crowd. Think of it like a crowd estimating jelly beans in a jar. Each individual guess is likely wrong. Some people will overestimate, while others will underestimate. But when we look at the collective, something fascinating begins to happen to the distribution of these errors. As we add more guesses to our pool, we calculate a running average. Initially, a few extreme guesses might pull the average away from the truth. But as the number of participants grows, the random errors on the high side start to cancel out those on the low side. The mathematical average of many independent guesses converges surprisingly close to the true count. The secret to this success is diversity. If everyone in the crowd shared the same bias, the average would be just as wrong as the individuals. In ensemble learning, we want our models to be independent and make different mistakes. When one model is overpredicting, another should be underpredicting, so their errors do not correlate. We can visualize these errors as vectors pulling away from the truth. One person's guess pulls to the left, another's to the right. When we combine these models, we are essentially adding these vectors together. Because the errors are random, they cancel each other out, leaving a final prediction closer to the center. Ensembles are also incredibly robust against outliers. Imagine one person gives a completely ridiculous guess, like a million jelly beans. In a single model, this would ruin the prediction, but here, the extreme voice is drowned out. The collective result remains stable, even when individual parts fail. Geometrically, you can think of each model as a jagged landscape of predictions. When we average these models, we are essentially smoothing out the landscape. The noise from one model fills the valleys of another, and the false peaks are leveled off. This smoother surface allows our final system to generalize better to new, unseen data. This principle is the foundation of some of the most powerful algorithms in AI. Instead of people guessing jelly beans, we have dozens of decision trees or neural networks. Each one is trained slightly differently or on different subsets of data. By aggregating their imperfect outputs, we produce a combined result that is more accurate and robust. Ensemble learning teaches us that there is incredible strength in unity and diversity. By embracing the imperfections of many individual models, we can craft a collective intelligence. If you found this deep dive into the wisdom of crowds helpful, subscribe to join our learning community. In our next video, we will explore the specific ways we can build these diverse models from scratch. Subscribe for more lessons on how collective intelligence improves machine learning models.